Pleasant good morning to one and all. This is Maria Pushpam, and for today's class, we are going to see the laws of radioactivity. So, coming to the laws of radioactivity, there are three laws. One is rate of radioactive disintegration, half-life period, and third one is average life period. I'll repeat: rate of radioactive disintegration, second one is half-life period, and third one is average life period. So all the three laws we are going to see for today's class. So I'll start with laws of radioactivity. First one is rate of radioactive disintegration. Rate of radioactive disintegration. So what do you mean by rate of radioactive disintegration is the rate of disintegration of radioactive element at any instant is directly proportional to the number of radioactive atoms present at that time. I'll repeat. So what do you mean by rate of radioactive disintegration means it's a rate of disintegration of the radioactive element at any instant will be directly proportional to the number of radioactive atoms present at that time. So this we call it as rate of radioactive disintegration. ஸோ ரேட் ஆஃப் டிஸ்இன்டகிரேஷன் வந்து எதை டிபெண்ட் பண்ணியிருக்கோம்னா எந்த பொருளுக்கு பார்த்தாலும் வாட் எவர் ரேடியோஆக்டிவ் எலமெண்ட் வி டேக் இன்டு கன்சிடரேஷன் த ரேட் ஆஃப் டிஸ்இன்டகிரேஷன் ஆஃப் ரேடியோஆக்டிவ் எலமெண்ட் வில் பி டைரக்ட்லி ப்ரொபோர்ஷனல் டு த number of radioactive atoms present at that time. So minus dN by dt is proportional to n. Minus dN by dt is proportional to n, and this proportionality is removed by using a proportionality constant, that is minus dN by dt will be equal to lambda n, and n is called the proportionality constant, or we can call it as decay or disintegration constant. Decay or disintegration constant. So equation one can be put in the form minus dN by dt is equal to lambda dt. I'll repeat, minus n terms we are taking in one side and they are remaining on the other side. So minus dN by dt minus dN by n will be equal to lambda dt. Is it clear? So I'll repeat. So we have seen the rate of disintegration constant, that is rate of radioactive disintegration, can be written as minus dN by dt is proportional to n, and this proportionality is removed by a proportionality constant or disintegration constant lambda. So minus dN by dt will be equal to lambda n. So this can be written as minus dN by n is equal to lambda dt. So this equation on integration we get log e n will be equal to minus lambda t plus c, minus lambda plus c. Okay, so if I integrating, minus dN by n is nothing but ln n, ln n, and you take the minus on the other side, so thing becomes minus, actually the thing is minus ln n will be the answer. You take minus on the other side, so thing becomes ln n will be equal to minus lambda t plus c, and c is nothing but the constant of integration constant. We can call it as constant of integration. C is nothing but integration constant. To find the value of c, we have to substitute the value of t as t0 and n as n0. I'll repeat. ஸோ என்ன பண்ண போகிறோம்னா சியோட வேல்யூ கண்டுபிடிக்கணும் இன்டெகிரேஷன் கான்ஸ்டன்ட்டுக்கு. ஸோ நம்ம என்ன சப்ஸ்டியூட் பண்ண போகிறோம்னா t is equal to 0, time is equal to 0, n is equal to number of radioactive atoms is equal to n0. So if you substitute both the things in the equation, we get the answer as t is equal to 0 and n is equal to n0. We get ln n0 will be equal to c. Is it okay? So now you substitute the value of c in this third equation. Is it clear with the point? So you get the final answer as ln n will be equal to minus lambda t plus log e n0. I'll repeat. So you substitute the value of c in the equation 3, you get the answer as log e n will be equal to minus lambda t plus log e n0. Is it okay? So now you make all the logs to come to one side. So what happens here is you write the thing as log n0 by n. Log n0 by log e is nothing but ln. Okay. So log e n0 by n will be equal to lambda t. Or we can write, you convert this ln to log. Log e can be converted to log 10. So you multiply the value by 2.303. So you get the answer as 2.303 log to the base 10 n0 by n will be equal to lambda t. Or simply you can write lambda is equal to 2.303 divided by t into log 10 to the base 10 n0 by n. Log n0 by n to the base 10. Is it okay? So I'll repeat this whole derivation once again. So initially you are having the term minus dn by dt is proportional to n. Now you remove this proportionality, you are equating the equation. So you remove the proportionality and you put equal to lambda n. So now lambda is called as proportionality constant. It can be called as decay or disintegration constant. So equation becomes minus dn by n will be equal to lambda dt. Is it okay? So now you integrate this equation too. We get the form. If you integrate this particular equation, we get minus ln n will be equal to lambda t plus, you make the, put this minus this side, you get the answer as ln n will be equal to minus lambda t plus c. Minus lambda t plus c. And you put, to find the value of c, what you have to do here is put t is equal to 0 and n is equal to 0. T is equal to 0 and n is equal to 0. You get the answer as n is equal to n0 and t is equal to 0. You get the answer for c as log n0. Log to the base e n0, which is said as ln n0 is equal to c. You can either write it as ln n0 or you can write log to the base e n0. And you get the final format. You substitute these values in equation 3. So you substitute the value of c in equation 3. You get the format log e n will be equal to minus lambda t plus log e n0. Now you make all the logs to come to one side. That is log n0 minus log n will be equal to lambda t. Or simply you can write the thing as log n0 by n will be equal to lambda t. And now you get the form. Log e can be written as log 10 simply by multiplying the value by 2.303. So you get the final answer as 2.303 log n0 by n to the base 10 will be equal to lambda t. Or simply lambda will be equal to 2.303 divided by t into log n0 by n to the base 10. So this is something about rate of radioactive disintegration. Rate of radioactive disintegration, the value lambda is equal to 2.303 divided by t into log n0 by n to the base 10. Is it okay? So now I'll go with the second law. Second law is said to be half-life period. So half-life period na enna, the time required to disintegrate 1/2 of the initial amount of radioactive element is called as half-life period. I'll repeat. What do you mean by half-life period is, it's the time required to disintegrate 1/2 of the initial amount of the radioactive element is called as half-life period. So irukka substance வந்து பாதி substance வந்து எப்போ 100% இருக்குன்னா எப்போ 50% decay completely disintegrate அல்லது decay ஆகுதோ, that we call it as half-life period. So is it clear? The time required to disintegrate 1/2 of the initial amount of the radioactive element is called as half-life period. In other words, half-life period is the time in which half of the radioactive element will disintegrate. So T is equal to, small t can be written as capital T or T half, and n is equal to n0 by 2. I'll repeat. So t is equal to capital T, or simply you can write t half. T is equal to t half, and n is equal to n0 by 2. N is equal to n0 by 2. So using this n is equal to n0 by 2, we get the form n0 by n will be equal to 2. You bear in mind, okay. I'll repeat. So n is equal to n0 by 2. If you, we can modify and write it as n0 by n is equal to 2. And now you substitute in the initial equation, you get lambda is equal to 2.303 divided by t into log n0 by n. That is our original equation. Okay. So now what you are going to do is, you substitute the values. T will be equal to 2.303 divided by lambda. Instead of where we are putting t, you put it as lambda. You are substituting the value as if where we are putting t, we have to put it as lambda, and lambda can be modified as t. Is it okay? So if it is lambda, we have to put t down. If you are going to calculate t, that is half-life period, you have to put lambda down. Is it okay? So the equation becomes t is equal to 2.303 divided by lambda into log n0 by n is nothing but log 2. So the equation becomes 2.303 into 0.3010, which is the answer for log 2, divided by lambda. So the final answer becomes 0.693 divided by lambda. I'll repeat. So half-life period will be equal to 0.693 divided by lambda. Is it clear? So I'll repeat the whole thing once again. So what I mean by half-life period is, half-life period is the time required for half of the substance to disintegrate. That we call it as half-life period. And for half-life period to calculate in the form of equation, we have to substitute t is equal to capital T, or you can put t half, and n is equal to n0 by 2. Substitute in the previous equation what we have derived. So we get the form lambda is equal to 2.303 divided by t into log n0 by n. And now we know the value. Is it okay? So now you get t is equal to 2.303 divided by lambda into log n0 by n is nothing but 2. And we know the log 2 is nothing but 0.3010. So you substitute the value, you get the final format. 2.303 into 0.3010 will be equal to 0.693. If you multiply both the values, you get the answer as 0.693 divided by lambda. So t is equal to, a half-life period is equal to 0.693 divided by lambda, and it's independent of the initial amount. Is it okay? So now I'll go with the third one. Third is called as average life period. Average life period. So what I mean by this average life period is, it's a amount of radioactive substance disintegrate one after the another. Hence all the atoms do not have the same life period. The atoms which disintegrate earlier will have short life, whereas others will have a long life. The ratio of the total life period of all the atoms of radioactive element to total number of atoms present in it is called as average life period. I'll repeat. So if you take a bunch of atoms, what happens there is, few will undergo disintegration first and the remaining will undergo disintegration later. So the one which is going disintegration first is said to have short life period, and the other one is said to be long life period. So now how to calculate average life period? It's a ratio of the total life period of all the atoms of radioactive element to the total number of atoms present in it. Total number of atoms present in it, and it's called as average life period. புரிஞ்சுதா? average life period எப்படி கால்குலேட் பண்ணணும்னா, எல்லா இப்போ ஒரு குரூப் ஆஃப் ஆட்டம்ஸ் இருக்குன்னா எல்லாம் ஒரே டைமில் வந்து டிஸ்இன்டகிரேட் ஆகாது. கொஞ்சம் சீக்கிரம் டிஸ்இன்டகிரேட் ஆகிடும், கொஞ்சம் இது வந்து லேட்டாக டிஸ்இன்டகிரேட் ஆகும். ஸோ என்ன பண்ணணும்னா, ஆவரேஜ் பார்க்குறதுக்கு யூ ஹாவ் டு டேக் த ரேஷியோ ஆஃப் தி total life period divided by total number of atoms present in that particular time. Is it okay? And this we call it as average life period. So it's a reciprocal of disintegration constant. So Ta will be equal to 1 by lambda, and we know the value of T is nothing but 0.693 divided by lambda. We have calculated in half-life period. T is equal to 0.693 divided by lambda. So we can modify the equation to the format lambda is equal to 0.693 divided by T. Lambda is equal to 0.693 divided by T. Now you substitute in the first equation, we get Ta is equal to T divided by 0.693. We are substituting the value for lambda. Is it okay? Because Ta is equal to 1 by lambda, we know the value of lambda is nothing but 0.693 divided by T. So you get the final answer as Ta is equal to T divided by 0.693. Or we can write T is equal to 0.693 into Ta. T is equal to 0.693 into Ta, or you can write Ta is equal to T divided by 0.693. Or simply we can write half-life period will be equal to 0.693 into average life period. Half-life period will be equal to 0.693 into average life period. Is it okay? So these are the three laws of radioactive disintegration. That is said to be laws of radioactivity. I'll repeat. So the things we have seen for today's class, the first one is rate of radioactive disintegration, second one is half-life period, and third one is average life period. So if you take this rate of radioactive disintegration, the final equation is lambda is equal to 2.303 divided by T into log n0 by n to the base 10. And in half-life period we have calculated T is equal to 0.693 divided by lambda, and in average life period T is equal to 0.693 into Ta, or simply we can write the thing as half-life period will be equal to 0.693 into average life period. I think you are able to understand the class, what I have taken for today's class. Continue studying. Thank you for listening. Continue studying. Thank you.